So for number 14, we are going to perform, or we are tasked to perform, interpolation on the given specific input. And interpolation is just the opposite of decimation, which is done in the previous item. For the code, again, we are just going to start with the usual clearing of everything, clearing of code, clearing of workspace, and clearing of all variables. For the setup, for the L variable, we are going to store there the input or the upsampling factor that the user would input. For the N variable, we're going to store there the length of the input signal that the user wish to have. And for the F1 and F2, we're going to enter there, or the user will going to enter there, the frequency of the first and second sinusoidal. For the next part, which is the X variable, this is the input signal that is going to be used for this output, and which is the cos sine 2 times pi times the frequency value times n plus cosine times 2 times pi times the second frequency that would be entered times n. Next, for the y variable, it's going to be stored there the value of the interpolated input. We're going to use there the interp function, which is for interpolating. The parameters of that function will be x, which is the input sequence, and then L for the upsampling factor that the user would enter. For the graph, we're going to use subplot 211, and the stem value parameters are n, x1, and the n. For the title of the graph, it is input sequence for the first graph, x-axis label of time, and y-axis label of amplitude. For the second graph, subplot 212, then m is equal to 0, then the n will be multiplied to L, which is the upsampling factor minus 1. And then for the title of that second graph will be output sequence. The x-axis label will always as usual time, and the y-axis label is amplitude. So if we run this code, now the MATLAB is asking us for the inputs. For the upsampling factor, we're going to enter 5. For the length of the input signal, we're going to enter 9, because the input signal should always be greater than 8. For the frequency of the first sinusoidal, we're going to use 0.1, and then 0.3 for the second sinusoidal. Then for the output, we can clearly see that it is the exact opposite of the previous item, because in this case, the input sequence has the lower sampling rate. As we can see here, there are significantly lower number of frequency or sampling rate that can be seen in the output waveform. Comparing the two, we can see here that for the time of the input sequence, it only is 8, and here is for the output sequence we have 45. And as we can clearly see, since interpolation is the process of increasing the sampling rate, it is clearly illustrated that in the output that was interpolated, there are more sampling rate and more frequency. So that is it for number 14.